Hello students, this is Mr. Estrada. I want to go over some of the questions in the review of rules of exponents and sequences. Um, I know there's a couple of questions here you're kind of stumped on, so I want to go over just a few of it in this packet. I will post up the answers of the entire review in the hub on Friday, so you can look over to see whether you got it right or wrong. So I want to start with the first one. Simplify the expression and use positive exponents. X to the 6th power times x to the negative 8th power. The rules of exponents says that you are going, since you're same base, different exponents, you're multiplying, you're going to add the exponents together. So you have x to the 6th power plus a negative 8th power. All right, and then you're going to add these together. So this becomes x to the negative 2 power. But since you can't have a negative exponent, remember the negative exponent means that you're going to take the reciprocal or the flip. So now this x to the 2 power will now be in the denominator part. So that means your correct answer is going to be C. All right, the next one, number 2. Simplify the expression, the same thing, use positive exponents. Now, since I am dividing here, I know I'm going to subtract the exponents. So in order to do that, I want to compare both the numerator and denominator if it has the same letter. And if it does, then I can be able to subtract. If it does not have the same base or the variable on both, then I'm just going to keep it where it is. So the first thing is p to the third. I have a p in the numerator part, but not in the denominator part. So the p to the third power is going to stay where it is in the numerator part. Then q to the 5 over 2, and then q squared. Well, I can subtract those together. So q to the 5 halves minus 2. Now, in order to subtract, you need to have common denominator. So I'm going to put this as a fraction, 2 over 1. And the common denominator is 2, so I'm going to have to multiply this, both the numerator and denominator, by 2. So this becomes q to the 5 halves minus 2 times 2 is 4. 1 times 2 is 2. That's 4 over 2. I subtract these, so this becomes q to the 1/2 power. And since it's a positive, I'm going to keep it in the numerator part. Now, the next one is r's. Now, I don't have an r in the numerator, but I do have one in the denominator part, and it's a negative. So, basically, you do the same thing like what you did in the numerator part, but except this r to the 6th power is now going to be in the numerator part. So, this is what I have in the numerator part. I don't have anything in the denominator part, so it's considered to be a 1. So, this, if you look at your answer choices, the correct answer is B. Number 3, simplify the expression, use positive exponents. Well, I need to simplify what's inside of the parentheses. Well, I notice here I have m to the third and m to the negative 1 power. So I will, since I'm multiplying, I'm going to add the exponents. So m to the third plus a negative 1, that is m to the 2nd power. So m to the 2nd power, and then n to the negative 5th power is going to be raised to the negative 3rd power. Now I have powers with powers. That means you're going to multiply it like you distribute it properly. So this times this will be m to the negative 6th power, and the negative 5 times the negative 3 is n to the 15th power. But that is not what it's asking. It says use positive exponents. So I know with the negative, I have to take the reciprocal of that. The n to the 15th power is going to stay where it is in the numerator part. Then the m to the 6th power, this negative means it's going to be in the denominator part now. So this becomes m to the 6, which is going to be letter D. All right, I'm going to go and skip to number 6. Determine whether the sequences are arithmetic, geometric, or neither, and why. Now, here with A, I have fractions here. You have to see whether you can add something to 3/5 to get 3/15. Same thing with the 3/15. What do you have to add to get 3/45? But when you're adding, you're going to add the numerator part, but the denominator is going to stay the same, and which is impossible. So what we're going to do is, let's see what we can multiply by 5 to get 15. 5 times 3 is 15. 15 times 3 equals 45. 45 times 3 is 135. And in the numerator part, I know it's 3 times what gives me 3? 3 times 1. And that's the same throughout. So if you look at it, it's a fraction that I'm multiplying by 3/5 to get 3/15, which is 1/3. And the rule is, in any time when you're multiplying, you will have a geometric. Why geometric? Because I'm multiplying each term or each number by 1/3. All right, let's look at B. Well, same thing. I have to see what I have to multiply by -6 to get -13. I'm doing geometric first. Well, there's no such thing as what I can multiply by 6 to get 13, because I know 6, the next number I know is 12, and after 12 it's going to be 18, so it's impossible. So let's see if I can do like add or subtract. Well, I can take whatever's the second term, -13, and minus it by -6. Okay, whenever you do that, you're going to subtract the second term from the first. Well, I see I have double negatives here. So double negatives turns into a positive, and then -13 plus 6 is a -7. So I'm just basically subtracting 7 in both everything. -7 is the same thing as -7. So -6 plus a -7 is -13. -13 plus a -7 is -20. -20 plus -7 is -9. So that is going to work. This is called arithmetic. And let me spell it here. Let's multiply by -7. Okay, let's go over to number 8. The following sequence is either arithmetic, geometric. I'm sorry, that's 8. I'm sorry. Number 8. The following sequence is arithmetic, geometric, or neither. If it's arithmetic or geometric, determine the next 3 terms in the sequence by calculating the common difference or the common ratio. Well, I want to see if what I can multiply by 540 to gives me 480. Well, you can try different things. You can do fractions, but it's impossible to get it. So let's see what I can do to arithmetic to see if it works. 480 minus 540. 480 minus 540 is -60. So this is -60. 480 plus a -60 is 420. 420 plus a -60 is -360. It works. So this is arithmetic. Now, what I need to find for the next 3 terms? Well, I'll just have to subtract 60 from 360, which is 300. So it cannot be C. And it cannot be D because we already know it's arithmetic. So 300 is the next term. And after 300, I subtract 60 from 300, which gives me 240. And after that, 180. So the correct answer is A. All right, number 10. Write the explicit formula for this sequence. I have to determine what type of sequence this is. So if I know I cannot multiply anything here, I can just use arithmetic. -12 minus a -20 Double negatives turns into a positive. Negative 12 plus 20 is negative 8. Or actually, it's going to be positive, excuse me. Positive 8, because the bigger number is positive than the 12. So, positive 8. So this one here becomes plus 8. This is going to be plus 8. And that is going to be my common difference. It's going to be my common difference. So that's going to be 8. Now the formula for arithmetic, and if you had that worksheet last time, the arithmetic explicit formula is a sub n is equal to a1 plus the common difference of n minus 1. A sub 1, that is your first term in the sequence. So that is negative 20. Plus your common difference here, which is 8. And then n minus 1. The n means that you're finding a specific number within the sequence. And in this case, we're not given that. So we're just going to leave it as n. So this is your equation, which means the correct answer is B. Okay, so let's move on to a couple more. And I'm just going to do 13 here because there's some confusion about when do you multiply. Okay, coefficients, that means numbers next to variables. That means you're going to multiply them together. So negative 3 times 5 is a negative 15. And then these are bases, the x's are bases, different exponents. So since you're multiplying, you're going to add these exponents together. So 2 is x is 2 plus a negative 2. And then I know that this 2 plus a negative 2, that is x to the 0 power. But anything to the 0 power is 1. Negative 15 times 1 is negative 15. Number 15, simplify. Well, anything to the 0 power, I know it is 1. So I just have to simplify this part in the parentheses, raised to the second power. This means 3x squared is raised to the second power. That means you're multiplying the 3x squared by itself. 3x squared times 3x squared. You multiply your coefficients. 3 times 3 is 9. Same base as my x's, 2's for both of them, so you're going to add these together. X to the 4. 16 to 17 is a review of rational exponents and radicals. So if I have the cube root of x squared, remember this one here, this is my root or my index, and the index or the root will be in the denominator part of the rational exponent. The power is going to be in the numerator part, and in this case, it's going to be 2. So if I have x, the numerator part is 2, because that's my power, and then the root is 3. So x to 2 over 3. Now I have a rational exponent. Now I just have to put it in radical form. This 5 here is my power. This 8 is my root. So the 8 will go in here outside. Oops, that's 8. The 8th root of what? X to the 5th power. Another way you can write this is the 8th root of x, but the whole thing is raised to the 5th power. That is also the same thing. Okay? So keep on working this review packet. If you have any questions, please ask me during class. So I hope you finish it and turn it in, and hopefully you'll be prepared for taking the exam next week. All right, good luck, guys.